Before we begin, a quick disclaimer. This video is for educational and informational purposes only. The information presented here does not constitute financial, investment, or business advice. You should always consult with a qualified professional before making any strategic decisions for your organization. The world of AI technology is complex and rapidly changing, and while we strive for accuracy, we cannot guarantee it. What if I told you that nearly 90% of all corporate AI projects are doomed from the start? That's not an exaggeration. A recent industry report revealed that a staggering 87% of data science and artificial intelligence initiatives never make it into production. Think about that. For every 10 companies pouring millions of dollars and thousands of hours into building the next generation AI that will revolutionize their industry, almost 9 of them will have nothing to show for it but a massive bill and a demoralized team. Their revolutionary ideas end up in the AI graveyard, a digital boneyard of failed proofs of concept, abandoned pilot programs, and brilliant models that worked on a laptop but collapsed under the pressure of the real world. Why? Why is the failure rate so astronomically high? It's because building enterprise-grade AI is brutally, punishingly hard. It's a chaotic symphony of mismatched parts. You have data scientists in one corner, writing code in Python using open-source frameworks like TensorFlow or PyTorch. You have IT and DevOps teams in another corner, trying to manage the underlying hardware, the GPUs, the servers, the networking, and wrestling with an alphabet soup of containerization tools like Docker and Kubernetes. And then you have the business leaders, the ones who sign the checks, asking a simple question: is it working yet? The answer far too often is no. It's not working because the specific version of that deep learning framework your data scientists downloaded from GitHub isn't compatible with the GPU driver your IT admin just updated. It's not working because a critical security vulnerability was just discovered in one of the 50 open source libraries your project depends on, and now you have to halt everything to patch it. It's not working because the performance you got in the lab on a single machine has fallen off a cliff now that you're trying to scale it across a dozen servers in your data center. This entire do-it-yourself approach has created what we call a Frankenstack, a monstrous stitched-together collection of software and hardware that is fragile, insecure, and nearly impossible to manage at scale. This is the silent killer of innovation. It's the reason your company's AI strategy is probably stuck in neutral. You see the promise of AI. You see your competitors talking about it. You know you need to be in the game. But the path from a great idea to a deployed, revenue-generating AI application is a minefield of complexity, cost, and risk. But what if there was a different way? What if you could eliminate 90% of that complexity? What if you could have a single, unified, enterprise-supported platform that handles everything from the silicon chip all the way up to the application layer? A platform that's been pre-tested, pre-optimized, and secured, allowing your team to stop being system integrators and start being innovators. That is the exact promise of the technology we are breaking down in this video. We are pulling back the curtain on the one platform designed to take AI out of the research lab and put it at the core of your business. We're talking about NVIDIA AI Enterprise. And my promise to you is this: by the end of this video, you will not only understand what it is, but you will understand how it works, and why embracing it could be the single most important strategic decision your company makes this decade. To really grasp the power of this platform, we first have to understand the broken world it was built to fix. Right now, we're in the middle of an AI gold rush. Every CEO, every board of directors, every startup founder is being told they need an AI strategy. And they do. But when they try to execute that strategy, they're typically presented with 2 terrible options. Option 1 is the DIY nightmare we just talked about, the Frankenstack. It gives you ultimate flexibility and control, which is great in theory. You can pick and choose every component from the vast world of open source software. But this flexibility is a trap. It puts the entire burden of integration, testing, performance tuning, and security patching squarely on your shoulders. Your incredibly expensive team of data scientists and AI engineers end up spending the majority of their time not building AI models, but acting as glorified IT plumbers, trying to fix leaks in a system that was never designed to work together in the first place. It's like deciding you want a Formula One race car, and instead of buying one from Ferrari or Mercedes, you decide to build it yourself from scratch in your garage by ordering thousands of individual parts off the internet. The odds of it ever finishing a single lap, let alone winning a race, are practically zero. This leads many companies to option 2, the cloud conundrum. You go to one of the big cloud providers, Amazon, Google, Microsoft, and use their managed AI services. This seems fantastic at first. It's easy to get started. You can spin up a machine learning environment with a few clicks. The plumbing is mostly hidden from you, but you soon discover the trade-offs. First, the cost. Cloud GPU instances are notoriously expensive, and those costs can spiral out of control with terrifying speed. You're paying a premium for convenience, and that meter is always running. Second, you face the issue of vendor lock-in. The more you build your AI applications using a specific cloud provider's proprietary tools, the harder it is to ever leave. Your data, your models, your entire workflow becomes tied to their ecosystem. And third, for many industries in the United States, like healthcare, finance, or government, there are serious concerns about data sovereignty and security. Can you or should you send your most sensitive proprietary data to a third-party cloud? So you're stuck. One path is a complex, risky, and slow do-it-yourself project. The other is an expensive, restrictive rental agreement with a cloud giant. For years, these were the only real choices. This is the fundamental problem that NVIDIA set out to solve. They saw this gap in the market and asked a revolutionary question. What if you could have the best of both worlds? What if you could get the performance, customization, and control of a custom-built system, but with the simplicity, security, and support of a fully managed service? And what if you could run it anywhere you want in your own data center in a public cloud, or even a hybrid of the both? That is the core idea behind NVIDIA AI Enterprise. It's not just another piece of software. It's a fundamental rethinking of the entire AI stack. The best way to think about it is as an operating system for AI. Let's use an analogy we all understand: your smartphone. When you use an iPhone, you don't think about the compatibility between the A17 Pro chip and the software that runs the camera. You don't worry about whether the drivers for the display are optimized to work with the graphics processor. Apple handles all of that for you with iOS. They've created a seamless, integrated, and highly optimized ecosystem where the hardware and software are designed to work together perfectly. Just works. This allows developers to focus on one thing: building amazing apps. They don't have to worry about the plumbing, because Apple has built the world's most stable and high-performance plumbing for them. NVIDIA AI Enterprise is the iOS for enterprise-grade artificial intelligence. It is a full-stack software platform that sits on top of NVIDIA's industry-leading hardware, their GPUs, and provides a complete, end-to-end operating system for building and deploying AI. It takes all of those disparate, conflicting, and insecure open-source components of the Frankenstack and replaces them with a single, cohesive, and fully supported platform. It includes everything from the low-level drivers and containerization tools, all the way up to the high-level AI frameworks, pre-trained models, and application-specific software development kits. Every single piece is tested, certified, and optimized by NVIDIA engineers to squeeze every last drop of performance out of the underlying hardware. And, most importantly, it all comes with enterprise-grade support. If something breaks, you have one phone number to call, not a random forum on the internet. You call NVIDIA. This completely changes the game. It transforms the role of your technical teams from maintenance crews into innovation engines. So how does that transformation actually happen? How do you go from firefighters constantly putting out infrastructure fires to architects designing the future of your business? It happens by fundamentally changing the ground your teams are standing on. For decades, building an enterprise-grade AI environment felt like trying to build a skyscraper on quicksand. You had the brilliant ideas, you had the expensive hardware, but the foundation was a chaotic, shifting mess of open-source components. Imagine you're a data scientist. Your job, your entire purpose, is to extract value from data. You're trying to build a model that can predict customer churn, or detect fraud, or identify anomalies in a manufacturing line. To do this, you need tools. You need a specific version of Python. You need a deep learning framework like TensorFlow or PyTorch. But that framework needs a specific version of NVIDIA's CUDA toolkit. And that CUDA toolkit needs a very specific NVIDIA GPU driver. And that driver has to be compatible with the kernel of the Linux operating system running on the server. If any one of those pieces is the wrong version, even by a minor point release, the entire stack collapses. It's a house of cards. This is a world known to every AI practitioner as dependency hell. It's where brilliant six-figure salary data scientists spend 50, 60, even 70% of their time not doing data science, but acting as amateur systems administrators. They're wrestling with compiler errors, hunting through obscure forms for a patch, and trying to figure out why the code that worked perfectly on their laptop suddenly explodes on the company's server. And for the IT department, it's a nightmare. They're handed this Frankenstein's monster of an environment and told, make it stable, make it secure, Make it scale. But how can you? The open source components were never designed to work together in a production environment. There's no single vendor to call for support. When something breaks, and it always breaks, it triggers a multi-team blame game. The data scientists blame IT blames the hardware vendor blames the open source software. Progress grinds to a halt. This is the core problem NVIDIA AI Enterprise was built to solve. It's not just a collection of software. It is a fully engineered end-to-end platform. Think of it like this. You could try to build a high-performance race car by sourcing an engine from one company, a transmission from another, a chassis from a third, and tires from a fourth. You might eventually get it to work after months of painful custom engineering, but it would be unreliable and impossible to maintain. Or you could buy a fully assembled, track-tested, and supported Formula One car directly from Mercedes or Ferrari. Every single component is designed, tested, and guaranteed to work together at peak performance. NVIDIA AI Enterprise is the Formula One car. It starts at the very bottom of the stack, the part that causes the most headaches, the operating system and the drivers. NVIDIA works directly with major enterprise OS vendors like Red Hat, Canonical for Ubuntu, and VMware. They certify their entire software stack to run on these specific platforms. This isn't a casual "it should work" guarantee. It's a formal enterprise-grade certification. This means you don't have to guess which Linux kernel is compatible. On top of that certified OS, you get the NVIDIA AI Enterprise driver. This isn't the same as the consumer-grade GeForce driver you download for gaming. This is a production branch driver, which means it's optimized for stability, security, and performance over chasing the latest features. It's rigorously tested for long-term deployments in data centers. This single step eliminates the number one source of system instability. The foundation is no longer quicksand, it's solid granite. But this is just the beginning. The real magic happens at the next layer. NVIDIA understood that the "it worked on my machine" problem was killing AI project velocity. The solution was containerization. For those unfamiliar, a container is like a standardized shipping container for software. It packages up an application and all its dependencies, every library, every binary, every configuration file, into a single isolated box that can run anywhere. NVIDIA AI Enterprise is built around this concept. They created something called the NGC catalog, which you can think of as a secure private app store for enterprise AI. Inside this catalog, you won't find random, user-submitted code. You'll find a curated set of performance-tuned, security-scanned, and ready-to-deploy containers for every major AI tool and framework you can imagine. Need the latest version of PyTorch, optimized to squeeze every last drop of performance out of your A100 GPUs? There's a container for that. Need TensorFlow with all the correct CUDA libraries already baked in? There's a container for that. Need a world-class inference server to deploy your finished models at scale? NVIDIA's Triton Inference Server is right there, in a container ready to go. This is a monumental shift. Your data scientist no longer wastes a week setting up an environment. They issue a single command to pull the certified container from NGC, and in minutes they have a perfect, repeatable, and fully optimized environment. The exact same environment can then be handed to the IT team for deployment in production. The "it worked on my machine" problem vanishes. It works everywhere because everyone is using the exact same standardized box. Furthermore, these aren't just vanilla open source versions. NVIDIA's engineers have gone deep into the code of these frameworks. They've optimized them specifically for NVIDIA hardware, integrating their own high-performance libraries like CUDNN for deep neural networks and DALI for data loading. This means that out of the box, you're getting performance that would take a team of specialized engineers months to achieve on their own. You're getting free performance, free stability, and free security. Now, having a bunch of containers is great, but in a large enterprise, you need a way to manage them. You might have hundreds of developers and dozens of projects, all needing access to a shared pool of expensive GPUs. You need a traffic cop, an orchestrator. And the undisputed king of container orchestration in the modern world is Kubernetes. NVIDIA AI Enterprise is designed from the ground up to be cloud-native. It integrates seamlessly with Kubernetes. NVIDIA provides a special piece of software called the GPU operator, which automatically handles all the complex plumbing needed to make Kubernetes aware of your GPUs. It manages the drivers, the container runtimes, and everything else. This allows your IT team to treat your GPUs just like they treat CPUs, as a schedulable resource. A data science team can simply request a pod with two A100 GPUs, and Kubernetes, powered by the NVIDIA operator, finds available GPUs in the cluster and allocates them. When they're done, those GPUs are automatically returned to the pool for the next job. This maximizes the utilization of your incredibly valuable hardware. No more GPUs sitting idle because someone forgot to release them. It creates a dynamic, elastic, and efficient AI factory. So let's take a step back and see what we've built. We have a certified, enterprise-grade operating system. On top of that, a stable production-ready driver. On top of that, a catalog of containerized, performance-optimized, and secure AI software. And managing all of it is a robust, industry-standard orchestration platform. This is the foundation. This is the boring, unglamorous, and absolutely critical work that no company should be wasting its own resources on. By providing this entire stack as a single supported product, NVIDIA AI Enterprise effectively outsources the complexity. It frees up your most valuable technical talent to stop being plumbers and start being architects. They can now focus on their actual job, building AI applications that create business value. The platform just works. It's stable, it's secure, and when something does go wrong, you have one throat to choke, one number to call. You call NVIDIA. And that is the peace of mind that allows innovation to flourish. But a strong foundation is only the first step. A foundation is useless without a skyscraper built on top of it. And this is where we move from the infrastructure to the application layer. Because on top of this rock-solid platform, NVIDIA has built an incredible suite of tools, pre-trained models, and software development kits (SDKs) that are designed to solve specific, real-world business problems. We're talking about AI that can see, speak, and understand human language, all available as pre-built workflows that can slash development time from years down to months, or even weeks. So let's make this real. Imagine you're the head of operations at a massive manufacturing plant. Your biggest headache? Quality control. You have a team of highly skilled inspectors, but they're human. They get tired, they blink, and sometimes a tiny hairline crack in a critical component slips past them. That one tiny mistake can lead to $1 million recall, a damaged reputation, and a logistical nightmare. For years, you've heard the promise of AI vision, cameras that can see better than the human eye. But the reality was always a team of PhDs, 2 years of development, and a mountain of custom code just to get a basic prototype working. It was a non-starter. This is precisely the scenario NVIDIA AI Enterprise is designed to shatter. Instead of starting from a blank page, you start with something called NVIDIA Metropolis. Think of Metropolis not as a single tool, but as an entire application framework, a complete blueprint for building world-class vision AI. It includes pre-trained models that already know what cars, people, and defects look like. It includes software that can track objects across hundreds of cameras simultaneously. It's the entire toolkit ready to go. So your team doesn't spend a year trying to teach an AI what a crack is. They take the Metropolis framework, connect it to the cameras on your assembly line, and within weeks, they have a system that is flagging 95% of the defects automatically. The AI doesn't get tired. It doesn't blink. It inspects every single unit with the same ruthless precision, 24 hours a day, 7 days a week. But here's where it gets really interesting. What about that last 5%? Your product is unique. It has specific types of imperfections that a generic model might not catch. This is where most AI projects hit a wall. You typically need a team of expensive data scientists to manually retrain the model, a process that could take another 6 months. Not with NVIDIA AI Enterprise. Included in the platform is a tool called the TAO Toolkit. TAO stands for Train, Adapt, and Optimize. And it's a game changer. The TAO Toolkit is designed for low-code or no-code AI development. It lets your existing engineers, the people who actually understand your product, take that powerful pre-trained Metropolis model and fine-tune it with your own data. They can feed it images of your specific defects, and the toolkit handles the complex process of retraining the AI. They don't need to be machine learning experts. They just need to be experts in your business. It's like taking a master chef's recipe and being given a simple set of instructions to adapt it perfectly to your own kitchen. Suddenly, that 95% accuracy jumps to 99.9%. The $1 million recall is off the table. This is a fundamental shift. The power to customize sophisticated AI is no longer locked away in a research lab. It's being handed to the domain experts on the factory floor. And this is just one example with one workflow. Let's stay in that same factory. The new vision system is working beautifully, but now you have a new problem. The factory floor is loud, chaotic, and workers need their hands free to operate heavy machinery. When a machine needs maintenance or a supervisor needs a status update, They have to walk over to a terminal, take off their gloves, and type it in. It's inefficient and can even be unsafe. What if they could just talk? This is where the next pillar of NVIDIA AI Enterprise comes in, NVIDIA Riva. Riva is to conversational AI what Metropolis is to vision AI. It's a complete framework for building and deploying AI that can understand and generate human speech. We're talking about real-time transcription, text-to-speech, and natural language understanding, all optimized to run with incredible speed and accuracy. Using Riva, your development team doesn't have to spend years trying to solve the incredibly hard problem of speech recognition in a noisy environment. They use Riva's pre-trained models, which are already best in class, and can quickly build a custom voice assistant for the factory. Now a worker can stand next to a machine and say, "Hey factory AI, what's the current temperature of bearing 7 on this press?" And a clear, synthesized voice instantly responds with the data. Or they can say, "Log a maintenance request for a hydraulic leak on line 4, and the system automatically creates a ticket, categorizes it, and alerts the right people. Productivity skyrockets. Safety improves. It feels like science fiction, but it's built using the same enterprise-grade platform that's already inspecting your parts. You're not buying a dozen different point solutions from a dozen different vendors. You're using a single cohesive stack. Now, you might be thinking this sounds great, but it also sounds incredibly complex to run. We have AI vision models running on hundreds of cameras, and now we have speech models running for hundreds of workers. How do you manage all of this without the whole system grinding to a halt? How do you ensure that when a worker asks a question, they get an answer in milliseconds, not minutes? This is the final, critical piece of the puzzle for today, and it's arguably one of the most important components in the entire NVIDIA AI Enterprise suite, the Triton Inference Server. If the AI models are the brains, Triton is the central nervous system. Inference is just the technical term for when a trained AI model actually does its job, when it makes a prediction, transcribes speech, or identifies an object. Triton is a piece of software that is purpose-built to serve these models at scale, with maximum performance. Think of it like an incredibly smart and efficient air traffic controller for AI requests. When a camera feed comes in, Triton directs it to the right vision model. When a voice command comes in, it routes it to the right speech model. But it does so much more. It automatically batches requests together to use the hardware more efficiently. It can run models from any AI framework, not just NVIDIA's. It can dynamically load models on different types of GPUs to balance the workload. It ensures that you are squeezing every last drop of performance out of your hardware investment. Without something like Triton, you'd have chaos. You'd have models competing for resources, slow response times, and a system that's impossible to scale. With Triton, you have a standardized, rock-solid, and blazingly fast production environment. It's the unsung hero that makes all of these incredible AI applications possible in a real-world, mission-critical business setting. So let's just take a step back and look at what happened here. Our hypothetical company went from a slow manual process to a fully automated, AI-driven factory floor. They implemented a state-of-the-art vision system using Metropolis. They customized it for their unique needs without a team of PhDs using the TAO toolkit. They deployed a hands-free voice-activated assistant using Riva. And they're running all of it at scale, reliably and efficiently, using the Triton Inference Server. They didn't just build an AI model. They deployed an end-to-end AI solution to a real business problem, and they did it in a fraction of the time and cost it would have taken just a few years ago. We've covered AI that can see and AI that can speak. But what about AI that can understand? Every company on the planet is sitting on mountains of unstructured data. Emails, reports, customer service chats, legal documents. What if you could unlock the intelligence hidden inside all of that text? What if you could build your own custom ChatGPT, trained on your own private business data, to answer questions, summarize documents, and even write code? That's where this is all heading. And it's the next massive leap in business transformation. And to make that happen, to build that custom private intelligence for your company, you can't just go out and buy a bunch of GPUs, plug them into a server, and hope for the best. That's like buying 1,000 Formula One engines and expecting them to magically assemble themselves into a race-winning car. The reality is, building enterprise-grade AI is brutally complex. It's a treacherous landscape of incompatible software, driver conflicts, dependency hell, and optimization nightmares. For years, only the tech giants, the Googles, the Metas with armies of PhDs could navigate this. For everyone else, it was like trying to build a skyscraper on quicksand. You'd spend 90% of your time and budget just trying to get the foundational plumbing to work, wrestling with open-source components that were never designed to work together at scale. You'd end up with a fragile Frankenstein's monster of code, a house of cards that could collapse with a single software update. This is the silent, frustrating barrier that has kept powerful custom AI out of the hands of 99% of businesses. So, how do you solve this? How do you tame this complexity? NVIDIA's answer is NVIDIA AI Enterprise. And the simplest, most powerful way to understand it is this: it is the operating system for AI. Think about the operating system on your computer right now, whether it's Windows, macOS, or Linux. What does it actually do? You don't really think about it, you just expect it to work. But under the hood, it's performing a series of miracles. First, it manages the hardware. It talks to your processor, your memory, your storage, making sure they all work together seamlessly. Second, it provides a stable platform with core services and libraries, so developers can build applications without having to reinvent the wheel every single time. And third, it gives you a way to easily run those applications. NVIDIA AI Enterprise does exactly this, but for the unique, massively parallel world of artificial intelligence. It's a full stack, a complete, integrated, and supported software platform that turns a pile of powerful hardware into a streamlined AI factory. Let's break down that operating system analogy, because this is the key to understanding everything. The first layer of any OS is the kernel, the deep fundamental part that directly controls the hardware. For your laptop, that's managing a single CPU. For an AI supercomputer, this means flawlessly orchestrating hundreds, or even thousands of GPUs, making them act as one colossal brain. This is incredibly difficult. NVIDIA AI Enterprise does this using specialized drivers and, crucially, something called the GPU operator for Kubernetes. Now, Kubernetes is the gold standard for managing modern applications across clusters of servers. What the GPU operator does is plug the GPUs directly into this management system, making these incredibly complex processors first-class citizens. It lets an IT team manage and allocate GPU resources as easily as they manage traditional computing resources. It's the foundational layer that makes large-scale AI possible and manageable, abstracting away the nightmarish hardware complexity. Okay, so the hardware is managed. That's layer one. What's next? The second layer of an OS is the toolbox it provides to developers, the core libraries, the runtimes, the compilers. On Windows, if you're a game developer, you don't write code to talk directly to the graphics card, you use a library like DirectX. It's a standardized, highly optimized toolkit that does the heavy lifting for you. NVIDIA AI Enterprise has its own DirectX for AI, but it's an entire suite of these toolboxes, each one purpose-built and obsessively optimized for a specific AI task. You've probably heard of some of them. CUDA is the bedrock, the fundamental programming model that unlocks the parallel processing power of the GPU. But then you have libraries like CUDNN, which is specifically designed to accelerate the deep neural networks used in almost all modern AI. You have TensorRT, which is like a magic supercharger for your trained AI model. It takes a model and optimizes it for pure inference speed, making it run dramatically faster and more efficiently in production. Think of it as taking a big, clunky research prototype and turning it into a lean, mean, production-ready engine. And then there's Triton Inference Server, a tool that lets you deploy multiple models built with different frameworks all at the same time, and it handles all the requests, the batching, the scaling. This isn't just a random collection of tools. This is an integrated, co-optimized suite. Each piece is engineered to work perfectly with the others and with the hardware underneath. This is what eliminates that Frankenstein's monster problem. You're not grabbing mismatched parts from across the internet. You're using a professional, fine-tuned mechanics toolkit where every tool is designed to work together. Now for the third and perhaps most important layer of our operating system analogy, the applications. An OS is useless without apps. Your phone is just a glass brick until you go to the App Store. NVIDIA AI Enterprise has its own version of an App Store, primarily through its NGC catalog. NGC, which stands for NVIDIA GPU Cloud, is a repository of enterprise-grade, pre-trained models, software development kits, and containers. A container, if you're not familiar, is like a complete package. It bundles up an application with all of its dependencies, so it can run anywhere without any compatibility issues. So, instead of starting from scratch, your data science team can go to NGC and pull down a state-of-the-art language model, or a computer vision model, or a data science framework that has already been tested, secured, and optimized by NVIDIA engineers to run perfectly on the platform. It's a massive head start. It's the difference between having to mine and smelt your own steel to build a car versus starting with a top-of-the-line, pre-built chassis and engine. So let's bring this all together and go back to our example. Building your own private ChatGPT. How would a company do it with NVIDIA AI Enterprise? First, their data scientists would go to the App Store, NGC, and pull down a powerful pre-trained foundation model like one from their NeMo framework. This model already understands language, grammar, and a vast amount of general knowledge. It's the pre-built chassis. Second, they would use the optimized toolbox, the CUDNN and other libraries, to fine-tune that model on their own private proprietary data. This could be their internal knowledge base, their customer support logs, their financial reports. This is what makes the model an expert on their business. Because the tools are all optimized, this training process is dramatically faster. And third, once the model is fine-tuned, they use another tool from the box, TensorRT, to optimize it for production, and then deploy it using the Triton inference server. The entire process, from development to deployment, is managed and orchestrated by the kernel layer, the GPU operator, ensuring stability and scalability. What you're left with is not just a piece of software. It's a complete solution to the biggest problems in enterprise AI. It boils down to three critical advantages: speed, stability, and security. Speed isn't just about faster chips. It's about speed to market. It's the speed of your team not wasting 6 months fighting with drivers and dependencies, and instead building value in weeks. Stability means it's an enterprise-grade product. It comes with full support from NVIDIA. When something breaks in the middle of the night, you have a number to call. The house of cards is replaced with the steel-reinforced foundation. And finally, security. This entire stack can be deployed wherever you want, in your own data center, on-premise, or in your private cloud. This means your most sensitive proprietary data, the very data you're using to create a competitive advantage, never has to leave your firewall. You aren't sending it to a third-party API. You own and control your AI end-to-end. This is the platform, the operating system, that takes AI from a chaotic, experimental science project into a predictable, scalable, and secure engineering discipline. And with this foundation in place, companies are now able to build some of the most mind-bending applications imaginable, far beyond just chatbots. They're creating entire virtual worlds, revolutionizing scientific discovery, and building the next generation of intelligent machines. And this is where the dream meets a brutal technical reality, because building these world-changing AI applications is not like installing an app on your phone. It's more like trying to assemble a Formula One race car in your garage, using parts sourced from a dozen different countries, with instruction manuals written in languages you don't understand. The promise is incredible, but the process for most organizations is a nightmare. Let's pull back the curtain for a second. To make an AI model actually do something, you need more than just the model itself. You need a massive, complex stack of software. It starts at the bottom with the hardware, the GPU. On top of that, you need a specific driver that knows how to talk to that GPU. Then you need the CUDA toolkit, which is the fundamental language for GPU programming. On top of that, you need specialized libraries like CUDNN for deep neural networks or TensorRT for high-performance inference. Then you need a framework like PyTorch or TensorFlow. And only then, at the very top of this precarious tower, can you place your AI model. Now here's the problem. Every single one of those layers is constantly being updated by different teams on different schedules. And a tiny change in one layer can cause the entire tower to collapse. You update a driver to fix a security bug, and suddenly your version of PyTorch breaks. You upgrade to the latest, fastest model, but it requires a newer version of CUDA that isn't compatible with your other libraries. This is a state of constant, agonizing chaos known as version hell. Data science and machine learning teams spend up to 80% of their time not on building amazing AI, but on just being IT plumbers trying to duct tape this leaky, fragile software stack together. They're wrestling with dependencies, debugging cryptic error messages, and recompiling libraries, all while their multi-million-dollar GPU clusters sit there, humming away, operating at a fraction of their potential. And even if you get it all working, there's another bigger problem. Is it fast? Is it optimized? Are you actually getting the full performance you paid for? Squeezing every last drop of power out of NVIDIA's hardware is a dark art. It requires a level of expertise that is incredibly rare and expensive. Most companies have the equivalent of a Ferrari in their data center, but they're stuck driving it in first gear because they don't have the world-class pit crew required to tune the engine. And finally, what happens when it breaks? When your critical, customer-facing AI application goes down at 3 in the morning, who do you call? With a hand-built open-source stack, the answer is no one. You're on your own, scrolling through forum posts from 6 years ago, hoping for a miracle. For any serious business, this level of risk, inefficiency, and uncertainty is completely unacceptable. This is the exact problem that NVIDIA AI Enterprise was built to solve. It's not just a piece of software. It is the official enterprise-grade operating system for AI. It is NVIDIA's definitive answer to the chaos. Think of it this way. Instead of shipping you 1,000 car parts in a box and wishing you good luck, NVIDIA is handing you the keys to a fully assembled, perfectly tuned, race-ready Formula One car, complete with a 24/7 world-class pit crew on standby. What NVIDIA AI Enterprise does is take that entire fragile software tower, from the drivers and CUDA toolkits all the way up to the models themselves, and it transforms it into a single cohesive rock-solid platform. Every component is selected, tested, and validated by NVIDIA engineers to work together flawlessly. They call it a golden stack. There is no more version hell because NVIDIA manages the entire stack as one product. When a security patch is needed, they release it for the whole platform, ensuring nothing else breaks. It's stable, it's reliable, and it's secure. But this is where it gets even more powerful. Inside NVIDIA AI Enterprise, you have something called NVIDIA NIMs, which stands for NVIDIA Inference Microservices. This is one of the most important developments in AI right now. Imagine you want to use a powerful model like Llama 3 or Stable Diffusion in your application. The old way involved a month-long project of downloading the model, finding the right software, compiling it, and then trying to optimize it for your specific GPU. It was slow and incredibly difficult. NIM changes everything. A NIM is a pre-built, pre-optimized, containerized AI model, ready to run. It's like an AI model in a box. It includes the model itself, all the necessary runtime software, and it's been hyper-optimized by NVIDIA engineers to run at the absolute maximum possible speed on their hardware. So now, instead of that month-long project, a developer can deploy a world-class generative AI model with a single command in about 5 minutes. They don't have to worry about the underlying software stack or the performance tuning, because NVIDIA has already done all of it. The NIM is a standardized, high-performance building block. It's like going from having to build your own car engine from raw metal to just dropping a perfectly tuned crate engine into your vehicle. This allows companies to experiment and deploy AI models at a speed that was previously unimaginable. They can swap models in and out, test new ideas, and go from concept to production in days instead of months. And remember that pit crew? That's the enterprise part. When you use NVIDIA AI Enterprise, you get direct access to NVIDIA's own experts. If you have a problem, if you need help with performance tuning, if something isn't working, you have a direct line to the people who built the hardware and the software. For a business investing millions of dollars into an AI strategy, this support is not a luxury. It is an absolute necessity. It completely de-risks the entire endeavor. It provides the safety net and the assurance that their mission-critical AI infrastructure is built on a foundation they can trust, with the backing of the world's leading AI company. So NVIDIA AI Enterprise isn't just a collection of tools. It's a fundamental shift in how AI is built and deployed. It takes the artisanal, chaotic, and risky process of building an AI stack from scratch and turns it into a standardized, reliable, and incredibly high-performance industrial process. It's the essential layer that connects the incredible promise of AI with the practical realities of running a business. So we have this perfectly tuned enterprise-grade AI engine, packaged into these simple, powerful NIM microservices, all supported by NVIDIA, the ultimate platform for building and running AI. But this raises the next, most critical question. Where does this platform actually live? Where do you run it? The answer might surprise you because it's not just in some massive, secret NVIDIA data center. It's designed to be everywhere. On your laptop, in your company's server room, and across every major cloud on the planet. And that is where the story gets really interesting. So let's pull back the curtain on this idea of AI being everywhere. Because when you hear that, it's easy to think of it as just marketing fluff. But this is the absolute core of the NVIDIA AI Enterprise strategy. It's the answer to one of the biggest, most expensive problems in technology today, the AI silo. For years, if a company wanted to build a serious AI application, they were faced with a terrible choice. They could build it on their own servers, their on-premise hardware, which gave them total control over their data and security, but was incredibly expensive to scale and maintain. Or they could build it in the cloud, giving them massive scalability, but forcing them to hand over their data to a third party, and potentially locking them into a single cloud provider's ecosystem forever. It was a classic rock and a hard place scenario. NVIDIA AI Enterprise is designed to shatter that choice. It's engineered to be a consistent, high-performance AI operating system that runs identically, whether it's on a server under your desk, in an Amazon Web Services data center, a Microsoft Azure cloud, or a Google Cloud Platform instance. This is a monumental shift. Think about it like this: you can write a document in Microsoft Word on your Windows laptop at home, then open and edit that exact same document on a Mac at the office, or even on your phone through a web browser. The application, the experience, the core functionality, it's consistent. You don't have to learn 3 different programs or convert the file into 3 different formats. NVIDIA is doing the exact same thing, but for the entire mind-bendingly complex world of artificial intelligence. Let's start with the most traditional environment, on-premise. This is the home turf for thousands of businesses, especially in sensitive industries like finance, healthcare, and government. They have their own data centers, their own server racks, and security is their absolute #1 priority. Their most valuable asset, their data, cannot leave the building. In the past, running AI in these environments was a nightmare. It required specialized hardware, custom software stacks, and a small army of PhDs to keep it all running. It was a science project, not a business tool. NVIDIA AI Enterprise flips that script entirely by integrating with the tools these businesses already use and trust. The 2 biggest players in the corporate data center world are VMware and Red Hat. These companies provide the virtualization software that lets businesses run hundreds of applications on a single physical server. It's the bedrock of modern IT. So what did NVIDIA do? They partnered deeply with both of them. This means an IT administrator who has spent their entire career managing virtual machines with VMware vSphere can now, using the same tools they already know, deploy an NVIDIA-powered AI environment with just a few clicks. They don't have to become a GPU or a CUDA expert overnight. The software handles the complex plumbing of connecting the virtual machine to the raw power of the NVIDIA GPUs. It allocates the resources, installs the right drivers, and presents a ready-to-use AI platform to the data scientists. This lowers the barrier to entry from an impossibly high wall to a simple step. It allows a company to leverage its existing multi-million-dollar investment in hardware and staff, and simply add a powerful AI layer on top. That is a game changer for enterprise adoption. But what if you're a startup with a groundbreaking idea, and you don't have a multi-million-dollar data center? Or what if you're a large company that needs to burst to a massive scale for a short period of time to train a huge model? That's where the cloud comes in. And NVIDIA AI Enterprise is a native citizen in every major cloud. You can think of Amazon Web Services, Microsoft Azure, Google Cloud, and Oracle Cloud Infrastructure. Now you might be thinking, wait a minute, I can already rent a GPU-powered virtual machine in the cloud. What's so special about this? That is the critical question. Renting a bare metal machine with a GPU is like buying a Formula One engine. Sure, you have the power, but now you have to build the entire car around it. You need to find and install the right drivers, the correct version of CUDA, all the deep learning libraries, and make sure they're all compatible with each other. It's a fragile, time-consuming process. One wrong version number and the whole thing falls apart. NVIDIA AI Enterprise on the cloud is like being handed the keys to a fully built, race-ready Formula One car, with a pit crew on standby. When you launch it from a cloud marketplace, you're not just getting a virtual machine. You're getting a fully configured, optimized, and most importantly supported software stack. All of those drivers, libraries, and frameworks are pre-installed, tested, and guaranteed to work together perfectly. And this isn't just a static image. It's continuously updated by NVIDIA with performance enhancements and security patches. Furthermore, it comes with enterprise-grade support. If your AI development team runs into a problem at 2 a.m., they can call NVIDIA, the people who built the hardware and the software, and get expert help. That level of assurance is priceless. It transforms the cloud from a hardware rental service into a managed AI platform. It lets developers focus on building their AI application, not on being a systems administrator. This brings us to the third and most common reality for modern businesses: the hybrid and multi-cloud world. Very few large companies live 100% in their own data center or 100% in a single cloud. They have a mix. They might keep their most sensitive customer data on-premise, use Azure for their office applications, and use AWS for their public-facing website. This creates a massive headache. How do you build an AI model that needs to access data from all 3 of those locations? How do you ensure the development environment your team uses on-premise is the same as the production environment in the cloud? This is where the consistent operating system concept truly shines. Because NVIDIA AI Enterprise is the same software stack everywhere, It acts as a universal bridge. A data scientist can build and test a model on a small dataset using an on-premise server. They can use the exact same tools, the same containers, the same software versions. Then, when they're ready to train it on a massive petabyte-scale dataset, they can take that exact same workload without changing a single line of code and deploy it onto a cluster of 1,000 GPUs in the cloud. Once the model is trained, they can deploy it for real-time inference back on their on-premise servers for low-latency predictions, or across multiple clouds for global reach. This develop once, deploy anywhere capability is the holy grail of enterprise IT. It prevents vendor lock-in, because you're not tied to a specific cloud's proprietary AI services. It drastically speeds up the time it takes to get an AI project from an idea to a reality, because you eliminate the friction and rework of moving between different environments. The secret sauce that enables this portability is something called the NVIDIA AI Enterprise Catalog. Think of it as a private, secure app store for enterprise AI. It's a curated repository of over 100 pre-trained models, frameworks, and tools, all optimized and certified by NVIDIA to run on the platform. And this catalog is the same, whether you're running on VMware in your basement or on Google Cloud in a data center on the other side of the world. It's the single source of truth that guarantees consistency. So we've established the where. On-premise, in the cloud, or a hybrid of both. We've seen how NVIDIA AI Enterprise acts as the consistent layer, the AI operating system, that makes this possible. But this just sets the stage. Knowing where you can run your AI is only half the battle. The real magic lies in what you can run. What exactly is inside that NVIDIA AI Enterprise catalog? What are these powerful pre-built tools and models that companies are now able to deploy anywhere they want with the click of a button? Because that's where we move from the infrastructure to the application, from the plumbing to the poetry of what AI can actually do. And that's exactly what we're going to break down next. So how do you actually build these world-changing applications? How does a company go from a mountain of raw data and a powerful server to a sophisticated AI that can talk to customers, predict market trends, or design a life-saving drug? This is where the magic truly happens. It's the leap from potential energy to kinetic energy. And it all happens within the application layer of NVIDIA AI Enterprise. Think of this layer as a 5-star Michelin-grade kitchen. The previous layers we discussed, the hardware, the drivers, the Kubernetes, that's all the essential infrastructure. It's the plumbing, the electricity, the industrial-grade ovens. It's absolutely critical, but it doesn't cook the meal. The application layer is the master chef's pantry and toolkit. It's stocked with the finest pre-prepped ingredients, specialized utensils, and proven recipes, all designed to help you create a culinary masterpiece fast. These ingredients and recipes are NVIDIA's AI frameworks and pre-trained models. And this isn't just a random collection of open-source tools. This is a curated, optimized, and fully supported suite of software that represents hundreds of thousands of engineering hours, all designed to solve specific, high-value problems. Let's make this real. Imagine a massive, nationwide retail company. Let's call them Omnicorp. Omnicorp is facing a crisis. Their customer service is overwhelmed. Their online recommendation engine is basic, just pushing the most popular items. And their supply chain is a mess, constantly overstocked on some items and sold out of others. They are sitting on a goldmine of data, decades of sales records, customer feedback, website clicks, but they're data-rich and insight-poor. They decide to go all in on AI using NVIDIA AI Enterprise. Their first target, customer service. They want to build a truly intelligent virtual assistant, one that doesn't just parrot a script, but actually understands, empathizes, and solves problems. A customer calls in frustrated saying, "My new coffee maker arrived, but the glass pot is shattered." The old, dumb chatbot would get stuck on the word shattered and offer a generic return policy link. Omnicorp wants an AI that can hear the frustration, identify the exact product from the customer's purchase history, check inventory for a replacement pot at the nearest warehouse, and proactively ask, "I am so sorry to hear that. I see you bought the Morning Brew 5000. I've already processed an order for a replacement carafe to be sent to you with expedited shipping, completely free of charge. It should arrive in 2 days. Is there anything else I can help you with?" That's a world of difference. But how do they build it? They don't start from scratch. Inside NVIDIA AI Enterprise, they find 2 key tools for this job: NVIDIA NeMo and NVIDIA Riva. First, NeMo. NeMo is a framework for building and training custom large language models. Omnicorp doesn't need to spend years and millions of dollars trying to build a foundational model like GPT-4. Instead, they take a powerful pre-trained model included with NeMo and fine-tune it on their own data. They feed it their product manuals, their internal knowledge bases, and tens of thousands of transcripts from their best human customer service agents. NeMo's tools make this process, which used to be the exclusive domain of PhDs, incredibly efficient. The model learns the company's specific language, its product catalog, and its ideal customer service tone. It learns what shattered carafe means in the context of the Morning Brew 5000. But a text-based model is only half the battle. People call in, they don't just type. This is where NVIDIA Riva comes in. Riva is a speech AI SDK. It handles the incredibly complex tasks of automatic speech recognition, turning the customer's spoken words into text and text to speech, turning the AI's response into natural, human-sounding audio. And because it's part of AI Enterprise, Riva is optimized for ludicrous speed. It can transcribe and respond in real time with minimal latency, so there are no awkward pauses. It can be trained to understand different accents, dialects, and even industry-specific jargon. So Omnicorp combines their NeMo-trained brain with the Riva-powered voice. The result? A world-class conversational AI, deployed in a fraction of the time it would have taken to build from scratch, all running on their optimized infrastructure, fully supported by NVIDIA. Okay, problem 1 solved. Next up, their recommendation engine and supply chain. They want to move from just suggesting popular items to predicting what a specific customer will want, even before they know they want it. They want to know that a cold snap in the Midwest is going to cause a spike in demand for electric blankets in Chicago next week. For this, they turn to another tool in the AI Enterprise kitchen, NVIDIA Merlin. Merlin is a framework specifically designed for building high-performance recommender systems. It's built to handle the absolutely massive datasets that companies like Omnicorp have. They feed Merlin everything. Every click, every purchase, every abandoned cart, along with inventory data, logistics information, and even external data like weather patterns and social media trends. Merlin provides the end-to-end pipeline to process this data, train a sophisticated deep learning model, and deploy it into production. The model doesn't just see that people who buy coffee makers also buy coffee filters. It sees nuanced, multidimensional patterns. It sees that customers in coastal California who buy organic coffee are also likely to be interested in a new brand of sustainable bamboo cleaning cloths, but only if they've browsed in the home goods section in the last 30 days. It's hyper-personalization at scale, and this same predictive power is applied to their supply chain. The model predicts demand not just for the whole country, but for specific regions, even specific stores. Omnicorp stops guessing and starts predicting. They reduce waste from overstocking and capture millions in lost sales from stockouts. Again, they didn't have to invent the complex algorithms for this. They used the specialized, optimized recipe provided by Merlin, and because it runs on the AI Enterprise platform, it can process terabytes of data and retrain the model daily, keeping its predictions razor-sharp. But they don't stop there. Omnicorp has hundreds of physical stores, and they want to bring this same level of intelligence into the real world. They want to understand how customers move through their stores, which displays are most effective, and how to improve store layout to reduce congestion. They also want to enhance security and loss prevention. The tool for this job? NVIDIA Metropolis. Metropolis is an application framework for AI-powered vision. It's a toolkit for building smart cameras and video analytics. Omnicorp uses Metropolis to process the video feeds from the existing security cameras in their stores. The framework provides pre-trained models for things like people detection and tracking. They can create real-time heat maps of their stores, visualizing which aisles are busy and which are being ignored, giving their merchandising team invaluable data. They can set up intelligent alerts. For example, if a checkout line gets longer than 5 people, the system can automatically ping a manager to open a new register. For loss prevention, the AI can detect unusual behavior, like someone concealing an item or loitering in a restricted area after hours, and alert security staff in real time. Crucially, Metropolis is designed to do this at the edge, processing video on-site to ensure privacy and reduce network bandwidth. It's about turning passive video streams into active, intelligent insights. So look at what Omnicorp has built. A conversational AI that delights customers, a recommendation engine that drives sales, a predictive supply chain that boosts efficiency, and intelligent stores that improve the physical shopping experience. They built all of this using the pre-built, optimized, and supported frameworks within NVIDIA AI Enterprise. NeMo, Riva, Merlin, Metropolis. These aren't just separate pieces of software. They are integrated components of a single cohesive platform. They are the poetry built on the plumbing. This is the core value proposition. It's not just about providing the GPUs, it's about providing the entire accelerated stack from the silicon all the way up to the AI solutions themselves. It's about dramatically reducing the complexity and time to value for any company looking to harness the power of AI. But this raises a critical question. We have the infrastructure. We have these powerful application frameworks. But where does it all live? How is it all managed, updated, and secured? How do you ensure that the NeMo model built by the data science team can be easily deployed by the IT operations team, whether it's in their own data center, in a public cloud, or both? This is the final, crucial piece of the puzzle. The management and orchestration layer that ties everything together. It's the conductor of this entire AI orchestra. And at the heart of this orchestration layer, this conductor, is a concept that has completely revolutionized modern IT. Cloud-native computing. Now, don't let the term cloud fool you. This isn't just about running things on Amazon or Google's servers. Cloud-native is a philosophy, an approach to building and running applications that are scalable, resilient, and portable. It's about taking the principles that allow massive web-scale companies to serve billions of users and applying them to your own AI infrastructure, wherever it may live. The cornerstone of this philosophy is a technology you've almost certainly heard of: Kubernetes. Think of Kubernetes as the operating system for your entire data center. In the old world, you had an operating system like Windows or Linux that managed the resources of a single computer: its CPU, its memory, its storage. Kubernetes does the same thing, but on a massive scale. It looks at a whole cluster of computers, a whole rack of servers, and treats them as one giant single pool of resources. It doesn't care if a program runs on server A or server B. It just finds available resources and runs the program. This abstraction is incredibly powerful. It's what allows for automatic scaling, self-healing applications, and the ability to move workloads around without any downtime. The way it does this is through something called containers. A container is like a lightweight, self-contained package that holds an application and everything it needs to run: the code, the libraries, the configuration files. It's completely isolated. This means an AI model packaged in a container will run the exact same way on a developer's laptop, on a server in your data center, or on a virtual machine in the public cloud. No more "well, it worked on my machine" problems. Kubernetes is the master scheduler for these containers, deciding which server gets which container, ensuring they have the resources they need, and managing their entire lifecycle. This is the standard for modern applications. But for a long time there was a huge problem. Kubernetes was built for CPUs. It understood how to manage general-purpose processors perfectly. But those massively powerful, highly specialized NVIDIA GPUs? Kubernetes had no idea what to do with them. It saw them as strange, unknown devices. Getting an AI application that needed a GPU to run on Kubernetes was a nightmare. It involved manual, brittle, and incredibly complex configurations. IT teams had to manually install specific NVIDIA drivers on every single server in the cluster. Then they had to install special runtimes and plugins. And if a driver needed an update, they had to do it all over again, server by server, hoping nothing broke in the process. It was a fragile house of cards that completely undermined the promise of automation and simplicity that Kubernetes was supposed to deliver. It was the single biggest barrier to bringing AI into the mainstream IT world. This is where NVIDIA AI Enterprise introduces its secret weapon. It's the tool that makes all this complexity simply disappear. It's called the NVIDIA GPU Operator. The GPU Operator is a piece of software that plugs directly into Kubernetes and teaches it how to speak fluent GPU. It automates every single one of those painful manual steps. When a new server with a GPU is added to the cluster, the GPU Operator automatically detects it. It then deploys the correct certified driver. It installs the necessary container runtimes. It configures all the required components. It turns the GPU from a mysterious, difficult peripheral into a first-class, fully managed resource, just like a CPU or memory. For an IT administrator, this is revolutionary. It's the difference between spending weeks manually configuring a cluster and having it done automatically in minutes. Need to update the drivers across 1,000 GPUs for a critical security patch? You don't log into 1,000 machines. You change a single line in a configuration file, and the GPU Operator handles the entire rolling update for you seamlessly without taking the whole system down. It makes managing a fleet of GPUs as easy as managing any other part of the data center. It's the easy button that enterprises were desperately waiting for. But AI at scale isn't just about the GPUs. When you're doing large-scale model training, you're often using dozens or even hundreds of GPUs working together on a single problem. The data has to fly between these GPUs at incredible speeds. If the network is a bottleneck, your multi-million-dollar GPUs will just sit there, idle, waiting for data. This is why high-performance networking like InfiniBand or ROS is critical. But just like with GPUs, managing this specialized networking hardware in a Kubernetes environment was another huge headache. And so, NVIDIA created the network operator. It does for high-performance networking exactly what the GPU operator does for GPUs. It automates the deployment of all the necessary drivers and software to unlock the full speed of the network fabric, making it another resource that Kubernetes can automatically manage and allocate. Together, the GPU operator and the network operator form the core of the management layer. They bridge the gap between the world of enterprise IT, built on Kubernetes and containers, and the world of high-performance AI, built on NVIDIA GPUs and networking. But NVIDIA didn't stop there. They knew that large companies don't just use vanilla open-source Kubernetes. They use hardened, supported enterprise-grade platforms. So NVIDIA AI Enterprise is designed to integrate perfectly with the tools these companies already use and trust. The biggest example? VMware. A massive percentage of the world's corporate data centers run on VMware vSphere. It's the dominant platform for virtualization. NVIDIA AI Enterprise is deeply integrated and co-engineered with VMware. This means a company can take its existing VMware environment, with its existing staff and expertise, and simply add AI capabilities on top. It allows them to carve up physical GPUs into virtual GPUs, or vGPUs, and assign them to different virtual machines, just like they would with CPU and memory. This maximizes the utilization of that expensive hardware and brings AI workloads into the same management console they use for everything else. The same deep integration exists for Red Hat OpenShift, which is the leading enterprise Kubernetes platform. NVIDIA AI Enterprise is certified to run on OpenShift, giving companies a fully supported end-to-end stack, from the hardware all the way up to the AI application, with a single point of contact for support. This is crucial for mission-critical deployments. And of course, this entire cloud-native stack is portable. The exact same containers and Kubernetes configurations managed by NVIDIA AI Enterprise in your on-premises data center can be deployed in any major public cloud, Amazon Web Services, Microsoft Azure, or Google Cloud Platform. This enables a true hybrid cloud strategy. You can develop and test a model on a small scale in-house, and when you're ready for a massive training run, you can burst to the cloud accessing thousands of GPUs on demand, all while using the exact same software and management tools. When the training is done, you can bring the finished model back on premises for inference where it might be cheaper or more secure. This flexibility is the holy grail of modern IT, and NVIDIA's management layer is what makes it a reality for AI. So, this orchestration layer does more than just conduct. It democratizes. It takes the highly specialized, complex, and formerly manual task of managing an AI supercomputer and puts it into the hands of the standard IT team. It uses the tools they already know, Kubernetes, VMware, OpenShift, and enhances them for the unique demands of AI. This dramatically lowers the barrier to entry, reduces operational costs, and most importantly, accelerates the entire process of getting an AI application from a data scientist's idea into a production system that delivers real business value. So we have the hardware, the foundational CUDA layer, the powerful software libraries, and now the intelligent management brain that orchestrates it all. We've built the complete platform from the ground up. But what does this actually look like in the real world? What are companies building with this incredible power? Let's start in a place where the stakes couldn't be higher. A hospital. Imagine a radiologist, one of the best in her field. She's staring at a brain scan. Her entire career has trained her for this moment, to spot the nearly invisible shadow, the subtle anomaly that could mean the difference between life and death. But she's human. She's on hour 10 of a 12-hour shift. She's looked at hundreds of scans today. The human eye, no matter how well trained, can get tired. The human mind can be distracted. Now imagine an AI co-pilot running silently in the background. This isn't some generic algorithm. It's a highly specialized model, trained on millions of anonymized medical images, developed and deployed using NVIDIA AI Enterprise. It doesn't get tired. It doesn't get distracted. As the radiologist examines the scan, the AI has already analyzed it, comparing it against a vast library of known conditions with superhuman speed and precision. It highlights a tiny cluster of pixels the radiologist might have glanced over, flagging it for a closer look. It's not replacing her expertise, it's amplifying it. It's a safety net woven from data and processing power. This is happening today. Hospitals like the University of California, San Francisco are using this platform to build tools that accelerate MRI scans by up to 40%, and to develop AI that can pinpoint cancer with incredible accuracy, giving doctors more time and more certainty. They're not just buying software. They're using the NVIDIA AI Enterprise stack to build their own bespoke, life-saving intelligence. Now let's leave the quiet of the hospital and step onto the deafening floor of a massive automotive factory. Here the stakes are different but just as high. A single robotic arm on a production line seizes up. A bearing fails. The entire line grinds to a halt. Every second of downtime costs thousands of dollars. Products aren't getting made. Deadlines are missed. The ripple effect is enormous. The old way of dealing with this was called preventive maintenance. You just replaced the bearing every 5,000 hours, whether it needed it or not. It was inefficient, wasteful, and it didn't even prevent all the failures. Enter the digital twin. Companies like BMW are using NVIDIA's platform to create a perfect, one-to-one virtual replica of their entire factory. Every robot, every conveyor belt, every sensor exists in this simulated world. This isn't just a 3D model. It's a living, breathing, data-driven copy. It's fed real-time information from the physical factory. The AI running on this digital twin can simulate weeks, months, even years of operation in just a few hours. It can see the future. It can detect the microscopic vibrations in that robotic arm that signal a bearing is starting to wear down. It doesn't just say, "This part will fail." It says, "This specific bearing will likely fail in the next 72 hours, during a period of low production." Here is the optimal time to schedule maintenance to cause zero disruption. They are literally forecasting the future of their machines, turning catastrophic, unplanned downtime into a scheduled 5-minute fix. This is the industrial revolution of the 21st century, and it's being built on this unified AI platform. But it's not all about saving lives and building cars. This technology is fundamentally changing how you and I interact with the world every single day. Think about the last time you had to deal with a customer service chatbot. You probably asked a simple question, and it gave you a link to an irrelevant FAQ page. It was frustrating, impersonal, and a complete waste of time. That's because most of those bots are little more than glorified decision trees, following a rigid, pre-programmed script. Now, companies are using NVIDIA AI Enterprise to build what are called large language models, or LLMs, for customer service. These are the same kind of technology behind tools like ChatGPT, but they are custom trained on that company's specific products, policies, and customer interaction logs. When you talk to one of these AIs, it understands context. It understands nuance. It can access your order history, understand the technical problem you're having with the product, and guide you through a solution in natural, human-like conversation. It can even detect frustration in your language and escalate the issue to a human agent seamlessly, providing that agent with a complete summary of the conversation so you don't have to repeat yourself. It transforms customer service from a cost center and a point of friction into a genuinely helpful, personalized experience. This is what companies like AT&T are exploring, aiming to solve customer problems on the first try every time. And it's in your shopping cart too. The best recommendation engines, the ones that feel like they're reading your mind, aren't just saying people who bought this also bought that. They are running complex AI models that understand style, compatibility, and even intent. They know you bought a camera last week, so they show you lenses and tripods, not more cameras. They know you just looked at hiking boots, so they show you waterproof socks and backpacks. They are becoming true digital assistants, personal shoppers powered by an enterprise-grade AI engine working behind the scenes. Let's go one level deeper, into the world of finance, where milliseconds can mean billions of dollars. The global financial system is a torrent of data. Trillions of transactions, stock trades, and credit card swipes happening every single day. For a fraud detection team, trying to find a criminal in that flood of data is like trying to find a single grain of sand in a hurricane. Human analysts can only review a tiny fraction of transactions, usually after the fact. Financial institutions like American Express are using NVIDIA's platform to build AI systems that can watch the entire hurricane in real time. These models can analyze millions of data points per transaction: the time of day, the location, the amount, your typical spending habits, and compare it against incredibly complex, ever-evolving patterns of fraudulent behavior. They can spot a stolen credit card number being used hundreds of miles from your home in less than a second. Declining the transaction before the thief can even put the card back in their wallet. They're not just following simple rules. They're learning and adapting, spotting new types of scams the moment they appear. This isn't just protecting a company's bottom line. It's protecting your money, your identity, and the stability of the entire financial ecosystem. So, from a doctor's screen to a factory floor to your phone to the global economy, this is what companies are building. They are creating intelligence. They are solving problems that were, until very recently, completely unsolvable. And the common thread, the enabling engine through all of it, is NVIDIA AI Enterprise. It provides that full integrated stack that allows a bank, a car maker, and a hospital to all start from the same powerful foundation and build the specific intelligence that their world needs. They don't have to worry about whether their software drivers are compatible with their hardware, or if their AI framework is optimized. It all just works. It removes the friction and allows the smartest people in every industry to focus on what they do best: solving problems. We have seen the hardware that provides the raw power. We've seen the software that shapes that power into intelligence. And now we've seen that intelligence at work in the real world, fundamentally reshaping our lives. It's an incredible picture of the present, but it begs one final crucial question. If this is what's possible today, where does this exponential curve of progress take us tomorrow? The answer to that question isn't found in science fiction. It's being engineered right now in data centers and labs around the world. The future that NVIDIA AI Enterprise is building isn't just an iteration of today. It's a fundamental phase shift in what's possible. It's a transition from AI as a tool to AI as a foundational utility, as essential and ubiquitous as electricity. First, let's talk about the end of guesswork. For all of human history, progress has been driven by a slow, expensive, and often dangerous process of trial and error. We build a bridge, hope it stands. We test a drug, hope it works. We design a car, hope it's efficient. This era is coming to a close. The future is built on simulation. We're talking about creating perfectly accurate, physically based, interactive digital twins of, well, everything. Imagine a complete, one-to-one digital replica of a jet engine. Before a single piece of metal is forged, engineers can run that engine in a simulated environment for 1,000,000 hours, under every conceivable condition. They can test 1,000 different new material compositions, 100,000 different blade designs, all in a matter of hours, at virtually zero cost and zero risk. The AI, running on the stable, scalable backbone of AI Enterprise, finds the single most optimal design, one that might have taken human engineers a century to discover through physical prototyping. Now scale that up. Don't just simulate an engine. Simulate the entire factory that builds it. An AI-powered digital twin of the facility can orchestrate the entire manufacturing process. It can predict when a machine will fail weeks in advance and order its own replacement part. It can reconfigure the entire assembly line in real time to adapt to a supply chain disruption on the other side of the world. This isn't just automation. This is a self-aware, self-optimizing industrial organism. But NVIDIA's ambition goes even further. They are building a digital twin of the entire planet. It's a project called Earth 2. The goal is to create a simulation of our global climate, so accurate that we can finally move from reacting to climate change to predicting it with unprecedented fidelity. We could see with terrifying clarity the precise impact of a policy decision before it's ever made. We could model the path of a hurricane with pinpoint accuracy days in advance, or predict the location of a drought years before it happens. This is a supercomputer problem of unimaginable scale, and the software stack that makes it manageable, that allows scientists from around the world to collaborate on this monumental task, is NVIDIA AI Enterprise. It provides the common language, the reliable infrastructure for humanity to understand and potentially save its own home. From simulating the macrocosm of our planet, we go to the microcosm of our own bodies. The next frontier is digital biology. Imagine a future where your doctor has a perfect digital twin of you, your organs, your cells, your unique genetic makeup. Before prescribing a medication, they can test it on your digital twin, seeing exactly how your body will react, eliminating the risk of adverse side effects. Drug discovery itself will be revolutionized. Instead of chemists spending decades mixing compounds in a lab, generative AI models, trained on the world's biological data, will design novel proteins and molecules from scratch, specifically engineered to target a disease. Projects like BioNIM, part of the AI Enterprise ecosystem, are the platforms where these life-saving AI models are born. We are on the cusp of curing diseases that have plagued us for millennia, not through guesswork, but through intelligent AI-driven design. This leads to the second major pillar of the future: AI as a creative partner. We've seen the first sparks with generative AI creating text, images, and code. But this is just the beginning. The future isn't about asking an AI to write an email. It's about collaborating with an AI to solve problems that were previously unsolvable. An architect won't just use AI to render a building. They'll describe the constraints, the budget, the materials, the environmental goals, the desired feeling of the space, and the AI will generate 1,000 viable, beautiful, and structurally sound blueprints for the architect to explore and refine. A scientist will describe a hypothesis, and the AI will design the experiment, analyze the data in real time, and suggest new avenues of research. This changes the very nature of human genius. It becomes less about having all the answers and more about asking the right questions. The AI becomes an infinite amplifier of human curiosity and ingenuity. But for this to work, for this to be reliable, these incredibly complex trillion-parameter models can't be run on a patchwork of experimental software. They need an industrial-strength operating system. They need the security to protect the intellectual property they generate. They need the stability and support to run 24/7 without fail. They need NVIDIA AI Enterprise, the hardened platform that turns a brilliant AI model from a fragile prototype into a dependable, mission-critical collaborator. Finally, and perhaps most importantly, all of this power coalesces into a future that is profoundly, deeply personalized. The age of one-size-fits-all is over. Your education will be tailored to your unique learning style by an AI tutor that knows exactly when to challenge you and when to support you. Your entertainment will be generated in real time, creating stories and worlds that adapt to your choices and emotions. Your health plan will be a living, breathing system, constantly updated based on real-time data from wearables, dynamically adjusting your diet and exercise recommendations to achieve optimal well-being. This level of personalization requires two things: immense computational power to run these individual AI models for billions of people, and an unwavering commitment to security and data privacy. This is where the enterprise in AI Enterprise becomes paramount. The framework is built with the security and governance tools necessary to handle the world's most sensitive data, ensuring that this personalized future is one that empowers the individual without compromising their privacy. So when we look at this future, a future built in simulation, a future co-created with generative intelligence, and a future delivered through hyper-personalization, we see the true role of NVIDIA AI Enterprise. It is the invisible, essential layer that connects everything. It's the common platform that allows a hospital in Ohio, a car factory in Germany, and a climate research institute in Japan to all build on the same proven, secure, and scalable foundation. NVIDIA didn't just build a faster chip. They built the entire stack from the silicon all the way up to the software, a complete end-to-end system for developing and deploying the most important technology of our time. They transformed AI from an academic pursuit into an industrial-scale utility. What the Windows operating system did for the personal computer, unlocking its potential for every desktop, NVIDIA AI Enterprise is doing for artificial intelligence, unlocking its potential for every industry. It is the operating system for the next industrial revolution. We stand at a remarkable moment in history. For the first time, we are not just discovering the world around us. We are designing the world of tomorrow with a new kind of intelligence. The challenges we face, from climate change to disease, are immense. But for the first time, the tools we are building might just be powerful enough to meet them. The platform is here. The infrastructure is built. The exponential curve of progress is steepening before our very eyes. The only question left is the one we must all answer together. What will we build with it?